Okay, guys, I'm going to kick this off. My name is Jim Masonbrink, and I'm the program director of the Small Business Hub based at Wright Brothers Institute. And I'm coming live from one of the Wright Brothers Institute facility, downtown Dayton. 444 is actually what it's called. That's where the small business office is, or my office is. And I want to welcome you guys to the Collider today. I believe this is the third Collider I've done with Illumination Works. Seems like everyone keeps getting better and better as the technology develops and everything. So it's I saw a little bit of yesterday's demo and stuff, and it looks really cool. I think you guys are gonna be excited. Just want to go over some rules of engagement of the Collider today. So if you have any questions that you would like to ask, please use the Q&A feature. Mr. Jim Blau, he's going to be looking at those questions as they come in, and vice versa. John will be looking at them and stuff too, as each one are speaking and stuff. So to help each other out. And if sometimes a Q&A feature can be a little buggy sometimes, but if you're having problems with that, please feel free to use the chat feature. Also, right now, why don't you go ahead and let us know where you're from in the chat feature, and that always helps us get a feel from, kind of connects us to everybody that's out there. Also, during the presentation, we're going to have some polling questions that's going to pop up a couple different times. You will be able to interact with us and fill out those questions. What that does is just gives us a sense of where everybody is in their in their evolution of the AI and the whole business aspect of it. So with that, I am going to turn this over to I'm not sure who's starting. Is it Jim or John?
Yeah, it's me. It's me,
okay.
Jim.
Great. Okay, I'm going to turn this over to Jim. He's going to share a screen, and we'll get this thing started.
So can everybody see my screen now? You see it, Jim?
You can see your screen, yes.
Fantastic. So we really appreciate the opportunity to talk to you today. And as Jim said, we've got two really exciting demonstrations that we have done and put together. These are all around making the most of sensors, whether that be a facility, a factory, or a lab. How can I take the sensors you have in each of those locations and make them smart? And this all revolves around the concept of Industry 4.0 transformation. So this is, there's a lot of different names for this, but this is the idea, and we'll describe that in a little bit more detail as we go through the session today. So as we get started, I'd like to introduce our speakers and presenters today. John Mitchell, who's the CEO and CTO of Illumination Works. And John will be taking us through the first part of the demos. And then Stefan Solzman. Stefan also is part of our team. Stefan is an AR IoT developer and designer. And I'm Jim Blau. Among other things, I focus on digital transformation within our organization. To give you an idea of what the next couple hours are going to look like as we go through this, we're going to start out and kind of just give you a level set of what this thing of industrial Internet of Things looks like, what it is, why it's important, why it's growing. We'll have a break for us to ask a couple of poll questions to get some feedback from you. Also, we'll get an opportunity at that point, if there are any questions, to take those at that point. Then we'll do the first of the two demos. The first one, which is the smart factory or smart facility type of construct. And this is around something that we're naming the Factory Advisor. And John will take us through that. He'll take us how we build it, and then he'll give you a demonstration of how it works. Again, we'll have a break for Q&A, and then we'll switch into a paint hanger demo that Stefan will do. And again, he'll give us all the background, how it was built, the tools. This is how we assembled it, show you what it looks like, the capability, We'll end up with another Q&A, and then we'll wrap everything up with additional feedback and a couple of final poll questions. So to get started, just to level set everybody, what is a smart factory? Or this could be a smart facility, this could be a smart lab. What does a smart entity look like? And this is really the ongoing automation of traditional manufacturing and industrial practices and processes. They leverage modern technologies such as IoT, which we'll define here in a second, advanced analytics, big data, and cloud. Things we can do today in 2021, we couldn't do 10 years ago. Matter of fact, until we have the environment we have with some of the tools available, some of those things were challenges. With the industrial Internet of Things, or IoT, that's where we connect people, products, and processes. And this is where we get into digital transformation. And a lot of people use that term. It's really just taking the available data and the tools and transforming your business. And we're going to use, in our case, an industrial IoT platform that companies that we partner with PTC so we can connect, we can monitor, we can analyze, and act on the data in new ways. There's a lot of data available, and we're going to see how much data and really where this is in this next slide. So if you think about it, this is a survey. There was some surveys and some numbers from last year, but they really pertain even today. And as a matter of fact, they're just growing by the year, by the month, and really by the day. So just to kind of just give you magnitudes, right? We're looking at 50 billion connected devices. We're looking at 35 zettabytes of data monthly. So there's all of these devices out there across a lot of different entities, and they just have massive amounts of data. And we see for companies, they see it's important. Companies realize that they need to invest in digital capabilities. We see that companies realize that traditional ways of doing things are obsolete. And one of the areas that we kind of focus on in both of our demos is this idea of predictive or prescriptive maintenance. How do I start with the data that's available to me? How do I start trying to determine what's going to happen and try to preclude an outage? So when we talk about being connected, we say it's products, people, and processes. And if we look at this graph, it kind of does a good job of showing that. Connected products are the ideas. I have a piece of equipment. I may have a machine in the lab. I may have something in my facility where I want to connect that. And I want to bring that information back. Sometimes it's to the original manufacturer. Sometimes it's to the organization. Smart connected people is really the idea is how do I connect with the people in my organization, especially in today's environment with COVID, right? People are remote. How do I provide that connectivity? And really the tool here, which we're not going to talk about today, is really that allows us to do that is augmented reality. And we'll mention it a little bit. What we're really going to focus on is this concept of smart connected processes, whether it be the construct that John is using or Stefan. This enables breakthroughs to be able to connect in an operational environment and make it more effective. And to build that, we need a platform, an architecture to build it upon. And this is the company that we work with and partner with, PTC. And the concept here is I have a digital thread, a information digitally that is across all of my organization, whether that be engineering, whether that be service, product and service innovation, or even sales and marketing. I have this common information that goes across all. Today, as I mentioned before, we're going to focus in this manufacturing area in our two demos. And here we're looking at how can I improve the operational efficiency? How can I reduce manufacturing cost? Also, making it safer for my workers, get things out to market quicker and have higher quality, higher compliance. And this is the way to do it. So if we look in today's environment, in whether it be in a factory, a lab, a facility, we have some common challenges. In the data side, right, we lack the visibility of operational information or machine data. I don't have that available to me, and I can't really see it. And sometimes it's because machines aren't connected, or if they are, I can't share it. Which leads me to the next point, is that I don't have the ability to aggregate it. Thus, I can't analyze it. I can't visualize that information. And because of that, reports are the information that's delivered to organizations are typically looking backwards. They're delivered after the fact. I don't look ahead and see what things I can do for my environment. Looking ahead, what I do is I look a lot of times what has occurred in the past. I have challenges from an infrastructure and IT standpoint. I have a lack of interoperability. Again, this concept of I have all of these different systems, I have different pieces of equipment, and they don't work together. And they stand very specific, very rigid. So I may have an application or system on my plant floor that doesn't communicate to my ERP system, or I may have a system within my lab that does not connect to some other type of system. So they are kind of they're all siloed type of systems. And mobility, which is one of the things we look at in today, because people are used to doing things on their phone, on a tablet, that's not available under this construct. If I look at maintenance and operational challenges, right, I am reactive in maintenance. I'm reactive when I do it because I don't have the information I need at the time. I can't really determine the root cause because I may only have part of the picture. I may know that a machine failed for some reason, but I may not have the bigger picture of it. And that's one of the things you'll show in our demos today is having all the information available on one piece of glass about our two operations. And thus it leads to unplanned downtime, which in any organization is one thing we really try to avoid. So for Illumination Works, what we leverage as part of it was the IoT platform is ThingWorks. This is from PTC, one of the leader in this space out of Boston, Massachusetts. If we look at what ThingWorks can deliver it's purpose built. It is built for an IoT environment. It has things that you would want to have: connectivity, scalability, security. And then it allows for rapid deployment, rapid development, and extendability. The idea is I can get something to value quickly. I can also go across all environments, whether that be on premises, whether it be in the cloud, or a hybrid of that. I also can provide a very engaging experience. So this is where I can take, whether it be a dashboard that's presented to me, or I can extend that with an augmented reality experience. And then it exists in a vibrant ecosystem. A lot of partners that we work with and existing with different systems. So the chances are there's some commonality between the systems in your organization and the support that ThingWorks can provide. So what makes up ThingWorks and what are the parts that we use today? From a connectivity standpoint, we look at Kepware, and you'll see John show us how that works and how we connected our factory. We then leverage a concept of a thing model. This is a tool to build really my IoT application. One of the key pieces of this, and what you'll see the next part of this is, it's codeless. The idea is I'm not a deep developer. I am using a tool that has widgets, drop downs, and templates that I can leverage. I then, if I want to create my UI, I look at this thing called a mashup builder. And again, both Stefan and John will talk about this in more detail. I can also easily write rules and generate alerts that I can put as part of my application. And then lastly is from an infrastructure standpoint is I can integrate with systems, whether they be business systems, whether they be systems within a factory. and web services. So the idea is it easily integrates. It provides a very unified view of various sources. So you're going to see all of these sources, and we can present that as part of each of our demos in a very unified fashion. And then being real time. And you'll see both John and Stefan show the capability of real-time monitoring of the different assets that are available. So I can now start making timely decisions, and I can also look ahead. I also can, accompanied with that, I can get instant notifications of alerts. So if something is wrong, I will know now. I'm not going to know 10 minutes later or et cetera. And you'll see actually when Stefan does the paint hanger, he actually has different icons that come up and says, you know, if I'm out of range in some of the different measurements that are occurring. I can real time provide and display that information. So I have all of the different assets, and you'll see again in both of them, you can see a dashboard that has all that information available to you in a real-time basis. And then I also have the capability of drilling down, and John will show us that in the first demo especially, where I can drill down, which then leads to really determining what the root cause is of a problem or getting more detail of what's going on within my operations. From a development standpoint, ThingWorx is really made to be able to develop faster and get quick time to value. So instead of having to develop it yourself, using tools which are available in the industry today, this is really going to accelerate your development cycle. And as I mentioned before, we can create a browser-based desktop and also mobile solutions. In our case, we're going to show 2 dashboards, but in the future, we could extend that out by showing it on a phone or a tablet. And I'll also be able to, because I now have the capability of looking at data real time across everything, I can now start doing data analytics that allows me to do predictive and prescriptive type of analytics. And we aren't going to show that today, but as we continue to grow these 2 scenarios, you're going to see them, we're going to see some done in the analytics space. And then finally, as I mentioned before, is I have the capability with augmented reality, with AR, to really integrate that. And as you can imagine, is trying to take what we've done and created and being able to view that in a very interactive type of experience. And that's something, again, that we're going to be looking to add to our 2 demos in the near future. So what is the value that's really delivered? And we've touched on some of these, but this is summarize that again, right? Proactive issue identification. I can do that. I'm not looking backwards, I'm looking forward. I have more reliable data collection. So everything is brought into one case. I don't have multiple screens. I don't have information that I have to run over and look at different systems. It's all collected in one central location. And thus, I get increased efficiency, increased flexibility within the environment. With, as I mentioned before, with all of these connected devices, being able to view them, manage them in one location is very valuable to your organization. As I continue to look at the value, right, unified visibility, so I can see everything at one spot, and you'll see again in both demos how that plays out. Faster remediation, so I real time can look at it. I then can make my action, and I can do it quickly and effectively. And thus I reduce downtime, which is a key piece. So if we kind of like bring these all up and really look at them, and this kind of like ties all that together, is what does ThingWorx bring? It increases the efficiency, it increases your responsiveness, improves the quality of your environment, and maximize uptime of your pieces of equipment. So we step back and we look at overall, what does this deliver? What does an IoT platform like ThingWorx deliver to your organization? And this maximizes revenue, or this could be maximizing the capital you're going to spend on a piece of equipment or the environment. how can I improve throughput, increase service levels, reducing cost? How can I lower labor costs? How can I reduce downtime? How can I make it more effective? Also, how can I provide a safe and compliant environment for the workers in my organization? And then increased efficiency. How can I improve the asset utilization for my company? So both of these, which we're going to go through today, come out of our innovation lab. Our innovation lab is at Illumination's headquartered in Dayton, Ohio. The lab is really about taking the latest technologies, the leading tools that are available in the industry, and really trying to exploit those for us to become more knowledgeable, for our consultants to become more knowledgeable, and then deliver solutions to our clients. Lately, the real focus for our company has been on AR, IoT, and data science. And we continue to grow those practices. We really follow the idea that we build it, we then rapidly prototype it, and then we will have a POC. And we're able to really accelerate the acceptance of the various cutting edge technologies. So hopefully that gave you a good basis for what we're going to talk about today. We're going to really go into the fun part of it, which is the two demos. Before we do, we're going to take just a quick break here for any questions that may have come up and or a couple of some poll questions. So one question that came up was, and maybe John or Stefan can help answer this. Our company has older equipment. Is IoT a reality for us? So maybe I've got a factory with older equipment, has never been connected before. Is that something that they can leverage with IoT? John, you got any thoughts on that?
Well, I'm sorry, what was the question, Jim?
About I have older equipment, and is IoT a reality for us? So I think what you're going to find, right, is there's a lot of ways, and we've actually worked with some clients with some pretty old technologies. We actually were in a job shop where they actually had some old technologies, which we were leveraging what they currently had and had a little bit of capabilities. But really the way ThingWorx works is the value of it is because of the maturity of it with Kepware, it really does go across almost all types of pieces of equipment and all types of protocols.
Yeah, and I think that the other piece of this is going to be, with older equipment, there are ways to add sensors to those pieces of equipment. And those are going to be targeted based on what you're trying to do. We've got customers that are looking at adding vibration detection equipment to existing CNC machines to specifically look at RPM speeds and tool wear. So older equipment, but the constructs around really the information we would glean from that is going to look at some of those operational contexts, things like RPMs, the type of tools that's in the current job, what kind of power load is it consuming, and there were some studies done at Sandia specifically around optimizing cut speeds and looking at vibration tones as a method to increase your throughput. So there are ways to add sensor packages to existing equipment. A lot of those are going to come from either aftermarket, or even in some cases some of the OEMs on different pieces of equipment, they're going to be offering add-ons to some of those other pieces of equipment. So it really just depends. We would want to drive that around what information are you trying to glean, what kind of optimizations are you looking for, and then make decisions on what's the best way to get that type of information from what you have.
Okay. Let's Jim, can you show the first of one of the poll questions? Okay, so we have 3 poll questions. We'd like to get just some feedback from you. Where is your company? Where's your organization in terms of IoT adoption? and you can look at this. You know, you're researching it, you may be prototyping it, piloting it, you may even be implementing it, or you haven't even, you may not even got started. Next question is, what is your top business challenge with what is the top business challenge with implementing IoT for you? So is that data in a siloed environment? Do not have real-time data available to me. I got a mix of different type of equipment, legacy and modern. I lack the knowledge and expertise, or it's a mix of the above. And then finally, the last question here in this spot is, if your company is looking at IoT options, are you considering something within the next 6 months, within the next year, within the next 2 years, or beyond that? Or maybe you're not even looking at it at all. So if you can, we can get some response to that, we'd really appreciate it.
That, and if we did not, if we were not able to get to your questions at this point, we will follow up post this webinar on these questions and get answers back to you. We want to make sure that you know, we're able to answer as many of these as we can, but we do have schedule constraints in terms of our presentation. So we'll get back to you at this afternoon or tomorrow with answers to your questions if we don't get to them.
Yeah, we'll have a couple more opportunities for breaks so we can do that. So with that said, John, I'm going to turn it over to you, and let's take us through the first demo.
Okay. Are you seeing my screen? Or are you?
I am.
Okay. So let's hop into the correct one. So what I'm going to go over for this section is going to be a demonstration of connected operations. Jim talked a lot about connected processes, you know, and ultimately, you know, for us, we had to come up with a scenario because this is a lab project. What made sense? What could we wrap our heads around from a business domain perspective? Because with everything, you know, we're interacting with people, we're interacting with pieces of equipment, and it comes down to what kinds of information do we care about? Like I mentioned earlier, what are the metrics that I need to see? What are the alerts that I need to see? What is important to my operations? So while we went down a factory specific use case here, the same kind of process can be applied, as well as the same kind of technology, to really any kind of facility management, labs, you know, industrial buildings, you know, medical devices, you know, whatever makes sense in the context of that. Because at the end of the day, what we're doing is we're connecting in a variety of different ways to things, and things can be databases down to things can be a sensor reading of humidity or temperature, things like that. So it's really a green field in terms of the data points that we can get access to, or the data sources we can get access to. And we'll talk a little bit about how that works within the ThingWorks platform. But for the sake of demonstration, you know, for those of you that have different potential use cases, you're going to have to do a little extrapolation to say, you know, this is how maybe I could fit into that, because this particular demo is very much focused on a smart factory construct. So, you know, setting this down, we had a couple different goals that we set out in our lab. We really wanted to be able to present the industrial transformation capabilities. What is the best way that we could simulate that with both real and or truly simulated pieces of equipment, in order to do those things like consolidate, measure, manage, and then ultimately for us, like Jim mentioned, leveraging our data science capabilities, we start to drive analytics, start to drive machine learning off these information sets. We wanted to combine a number of different sources in this project. So we would be getting data from multiple places and really showcase the flexibility of the ThingWorks platform. This also for us sets the stage for an iterative capability development and a learning model for us as a company, as well as to showcase the power of these tools and what you can do to exploit that data. So, once we identified our factory advisor or manufacturing kind of use case, we also tried to say, what kind of value would an organization get out of a capability like this? And so, things like keeping operations running, minimizing that repair, replace, maximizing uptime, things like condition-based monitoring and maintenance are big buzzwords, but they also have, we can drive real value by getting access to the raw data. We can identify environmental issues by connecting to the environmental systems and the sensors that you have on that for worker safety. And then also, if we're looking specifically at manufacturing data with CNC machines, certain types of data points on those, we can monitor and manage our quality escapes during the machining process. So, what are the ways that, some of the ways that, if this was a real use case with a real customer, these are the things that they potentially would be looking at. And that drove a lot of our discussion, design, and implementation. So just a high level, what does this look like? We have a manufacturing plant, and we have three main blocks of things that we care about that could be producing data. We have CNC machines. We have the ability to measure and monitor the power going into these systems, so we can look at that consumption and kind of compare that to manufacturing data. And then we have our environmental system. So we really have those three big chunks of things or equipment that would be generating information. Each one of these is going to give us a certain set of data. So for CNC machines, we're bucketing these into things like a job run. So as I build a particular part, I may change the tools multiple times. I may be cutting at different angles, different speeds. If I have a 3-axis or a 5-axis or even a 4-axis machine. So it's going to give me that data. As I run this job on this block, this is what I'm doing. And we'll showcase that. Power meter, pretty self-explanatory. We're going to look at power consumption across all the things that we can measure on the AC line coming in. And then from an environmental perspective, we're looking at environmental data. In this particular example, we have a working micro HVAC system that we'll show in a little bit. But we really wanted to make this as realistic as possible. So with that, I'm going to flip over to the demo. Everybody see my web page okay here? Factory Advisor, Jim?
Yeah, it looks good.
Okay.
Yep, got it.
So let me make sure I'm still logged in, not timed out. There we go. So as this pulls up, from a design perspective, you can see, and this is our main entry point from an application perspective, we really have those three pillars or groupings of information. We have our manufacturing sector, and in here we have a number of micro pieces of CNC data, and these are your high points. These are your things that if I glance at this dashboard, what do I want to see? So I'm looking at things like status. I'm looking at the program number. I care about the operating temperature. And then I've got this bit life indicator that is, showing me the current tool loaded, what kind of expected life does it have. And then across this bottom here, I have progress bars. In my center level, I have my energy consumption. So what am I currently doing? Obviously, pulling less than an amp here. We're not dealing with a lot of energy consumption, but these are live feeds coming off of a Dent Power Scout in our lab. So we're able to pull that data dynamically in and present that to you as a live feed. We also have the ability to drill into trend information. So we have last week's data. So you're seeing a couple different points here. And I have the ability to really have these live graphs, although a little bit hard to read here. You're looking at timestamps. You're looking at the different data points that we're pulling off and we're passing through the system and pulling on there. So eventually I could build a drill in. If I want to look at that particular data point at that particular time, I can make that active. For now, we're just showing it, as a trend line, a time series line, so we can gauge some of those things. And from a high level visibility perspective, look at that. Same thing here. The third pillar is going to be our environmental data. And at this point, it's pretty simple. We have temperature, humidity, and pressure. And there's some sensors that are providing us those data points. We also have trend information. And as you can see, as we've cooled off here the last couple of days in Dayton, our humidity has dropped from a high point just a couple of days ago when we had a big storm come through. So for me, it's great to see that the demonstrations that we're doing are reflective in the environmental controls, which is something that you can influence. But once again, same kind of construct. What is my push over time? How am I viewing that? We also have the ability to drill into more detailed pieces, and we're going to start on the environmental side. So I'm going to open up this page, and this is going to be my drilling. This is going to give me a lot more detail. This is going to give me a better visualize or an in-depth visualization of that. I also have things that drive my environment. I have different statuses of different pieces of equipment. In this piece, I have the system fan, or for us, it's a ventilation activity. The fan is on, and that's because the relay is on. So I'm providing power to it, and I'm measuring that, yes, I'm actually turning, I'm getting RPMs. So I also have the same kind of trend line over the last couple of days. As you can see, the humidity line is the one that kind of moves the most across the, the lab environment that we have. Up here, as you can see, we've moved to kind of this drill-in piece. So I have some navigation that we've created. And the key thing to think about and take away is it's really flexible in terms of what you want this to look like, as plain vanilla or as branded or as colored as you want. We chose colors that we thought made sense. And so, as we put this together, it looks like this, but it very easily could have a different look and feel. So if I go into the power view, I see the different power systems. I have graph legend activity, this energy consumption graph. Take a second to load there. And these are pretty steady. The system kind of just runs and turns on, so that it's not overly exciting to look at this graph. But we do have some variances in amperage and some highs and lows in volts as different pieces of equipment are turned on and turned off, because like I said earlier, the HVAC system is live. So as temperature thresholds are reached, we're actually spinning up heater controls and cooling systems to adjust that. From there, I'm going to start drilling into my manufacturing activity. And I could get to this page from that home page as well with those little plus boxes. But I'm going to be drilling into what is a simulated, specific job run. So same menu up here. I have general machine information. I'm looking at what is the program code. What are we trying to tell this machine to do? While this image right here is a video feed from just an overlook into our enclosure, what we're trying to simulate here or show is really any live stream video, live stream image. We can integrate that data as well. So if I had a video camera, a LiDAR camera, or something else that's looking at a 3D print job, or any kind of really feed, I could incorporate that visualization into my mashup, which is a UI in ThingWorks, and pull that data together. Once again, same status locations, spinous locations. Some of these are graphic adaptions that we've done more from a visual perspective. An indicator line is typically a good way to show lifespan or lack thereof. And then the other thing that you're going to notice here in this top bucket, as the job runs, we're getting those status notices. So I'm getting a live feed from this simulation machine. And as I get those live updates into ThingWorks, I'm able to push those directly onto the user interface. And we can drill into really any one of these machines. The video feed is going to be the same, but your program data in terms of what it's specifically doing are all going to be different. So with that, that's the end of the demo. And the next piece, we're really going to talk about what we built, how we built it, and a little bit of the why we did some of the things we did. So I'm going to flip back over to my PowerPoint and go from there. So as we set back, we defined our use case. We looked at this and said, we have an understanding of the domain. We have an understanding of who our actors are. We have a general understanding of what kind of data we would be getting and seeing. What are my building blocks? And so with ThingWorks, there are a set of pre-built applications. A factory advisor could be considered one of those pre-built configurable. There's a number that you can get directly from PTC or other partners, but they really are starting points for being able to configure or customize your own capability. You can also start from scratch, which really speaks to the flexibility of the tool set. My use case may be something completely different, and the ability to rapidly build that user interface, which we'll show you here in a little bit, is really one of the big strengths of the platform. We wanted to highlight connectors, and by connectors, we're really talking about what all kinds of ways can I access data, and ultimately every one of them being access data securely. But maybe I'm accessing control systems. Maybe I'm accessing an embedded system. Maybe I need to connect to a database because it's got information that I care about in the context of other information. And the ability to pull all that data together in a single location through all these connectors is another strength. I'm going to create a model, and I'm going to create a model based on the business or the operation that I'm doing. So in our construct, I have a thing called a Cnc machine. And that is a object or a thing in the model, and I'm going to associate all the data to that model. And what that allows us to do is make it very simple and easy to understand not only the data we're collecting, but how it's organized. We're going to apply business logic. In our case, some of it's pretty simple in terms of trends and other things, status indicators, bit life, or even some of the visualization pieces. Why do I care about looking at it in a blue color versus a red color? You know, that can be simple business logic that helps lead people to understand the information that's being presented. And then ultimately getting to, you know, as Jim said earlier, this drag and drop user interface creation. So I don't have to be a developer to be able to create really powerful user interfaces that showcase and demonstrate the information that I have. So let's drill into a couple specifics here. So from an edge perspective, we definitely wanted to be able to simulate controls data. So we're using a product or a sub-product called ThingWorx Kepware Server. And what that really is a gateway to all of my controls data. A number of drivers for known protocols, OPC, Modbus, MQTT, but those are going to be direct connect native interfaces to various devices, various drivers. I think the count is somewhere in the 200-ish, and then with derivatives off of that in terms of the number of different drivers that are part of the suite that can be licensed on a subscription basis. For us, we're using BACnet because we're connecting to Honeywell systems, and those systems are talking to each other over a BACnet protocol. Why do we do this? Really, it's to reduce the complexity and to reduce the amount of traffic that is on our controls network. So if we're running a BACnet protocol for our controls network over a serial connection, which is, you know, old line-based connectivity between a Honeywell room controller and a Honeywell building controller, I don't want to push requests of data from ThingWorx or Kepware back and forth on that network. So what we're going to do is we're going to centralize or consolidate those data pushes, and in our case, actually up to a building controller level, which we'll talk about here in a little bit, so that I've really only got a single access point to that controls network. It simplifies the connectivity and also reduces that bandwidth load on our networks. Big picture, ThingWorx architecture chart. We're not going to use all of this in our demonstration today. We have plans for using different pieces in later iterations, but this is a chart that you'll see or similar ones on the website. So in the context of make unified and understanding kind of what we're doing here, we're connecting to those edge devices, those controllers, those sensors, and we're pulling off those data points. And we're doing that through our Kepware server, as I mentioned. We're pulling that data into ThingWorx, and Composer is our interface that allows us to configure the business model, allows us to handle looking at what kinds of trends, what kinds of clustering, what kinds of insights can we glean from the sensor information that we're pulling off of these things. Also, as part of this technology capability enablement, we have the ability to pull in and integrate augmented reality. So I can have AR visualizations of my sensor data wearing a Microsoft HoloLens through an iPad AR experience and be able to look at my factory and show the data on, floating in space on top of the machines that are producing it. So those would be things that we explore later. Those capabilities are readily available today, but we have not got a particular project. Now, what did we build? A little bit of that side. Yes,
John,
sir?
I want to interrupt you just a little bit. I'm getting some broken up audio from you. Do you mind maybe just shutting off your video, and that might increase your bandwidth a little bit?
We'll do that. Okay, I'll try again. Interrupt me if.
Sure. I apologize if I interrupt you there. I just wanted to.
No, appreciate it.
Okay.
Because I think I sound fine.
Yeah.
So
I'm back on mute.
yeah, exactly. So a little bit of a mad science project, I think, in terms of what we physically constructed. But once again, we wanted to make this as real as possible in the confines of our offices in Beaver Creek. So we have a functioning HVAC system with air conditioning, sensors, vent fans, and heaters. We're using thermoelectric chips to do that activity, but the system will blow cold air and hot air and then be able to control itself with those different sensors. We're also have power switches that are either switches or relays. So the ability to dynamically and electronically through bit level interaction, turn these pieces of equipment on, turn them off, is a part of the physical plant piece of this simulation. And then we also have the ability to measure the power consumption. For each one of these, this is our controls network. So we have a WebRL6N that is a room controller made by Honeywell. And that's the brains of monitoring and managing and turning all these different pieces on for that HVAC system and that digital switch controls. We have a Dent Power Scout that we have lined in measuring our power consumption. Both of those are talking to a server, basically. It's a Honeywell Titan 8000. So think of this as more of a building level controller. Many different things can be connected to it in series so that we can use it as a consolidation point. The other dynamic of what we've done here is we're pulling all of our data only from the Titan. So each one of these two devices that's below it are sending their data to that server, and then the server is exposing that to us, to Kepware. From there, we have a live connection into ThingWorks, and we're mapping that data. So there's an endpoint in ThingWorks where we're recording that information. And then from there, that's where we're creating our domain model and then building our user interface. Cnc Machine Simulation went a little bit left field. So we're using microprocessors, physically don't have the power or the space to have a CNC machine in the office here. So what's the next best thing is our ability to simulate that data based on sample data that we were able to acquire and really generate scripts to allow us to test our hypotheses and our code. So we have a semi-dynamic connection to ThingWorks. We're doing secure HTTPS REST posts. The scripts we're running are actually generating information and then sending them to ThingWorks, which we have mapped to a thing, which I'll show you here in a little bit. That same thing then can be pulled into our mashup. So I'm getting microprocessor data and I'm getting sensor data all into that same user interface. For those that are code junkies, pretty simple code to do that secure post. Simple Python code. I tell it where my server is. I give it a security key that is a single identified key. I go over an encrypted channel. I tell it where do you want to put the data? In this case, it's CNC remote thing 11. I give it some parameters. I set some values, and I just do a HTTP put or a send basically to that server, and then ThingWorks consumes that and puts it in the right place. So we're going to do a smart factory walkthrough in terms of the weeds. We've got a quick video overview. We'll talk about the Honeywell interface. What does it look like? What are the different piece parts that we used in order to build this? We're going to talk about the Kepware setup. So what did I have to do to connect those controls to Kepware? We're going to talk about the ThingWorks connections. So how am I getting data there in Kepware? The process to define things or build our domain model, and then just a snippet of the user interface build activity from a drag and drop perspective. So I'm going to show this video. So here we have our digital switches. We have our power relay, or excuse me, our power consumption, our Honeywell Titan and WebRLN room controller. As you can see, we're running BACnet, different sensor pieces. That's a pressure sensor, some relays, our heat dissipation for our cooling system, and then our cute little 3D printed microprocessor CNC models. Running live data in a couple rooms over from me now. So with that, I'm going to flip over to an interface. And log into my Honeywell system. Well, maybe not. Try that again. There we go. So this is the web interface for our Honeywell system, and I'm logged into that Titan 8000. So if I open up this box 2, which is going to be the brains of our HVAC system, this is the visualization that I'm able to get access to. This was built a number of months ago, but I have all of my data points that I'm collecting being pulled into this single interface. I have my sensor information, humidity, temperature, pressure information. I have statuses of various relays. Are they on? Are they off? I have the ability to interact with my system. So set things like set points for temperature, set points for alerts. So this interface was built not only to give me that visual display to compare data points to, but also for me to actually do things like turn things on and off electronically via the control system versus going up and hitting the power button. All of these data points are going to be exposed in this point thing as I go to a property value. And so what you're going to see here over the next couple of minutes is the theme of, I have a data point here, I'm rolling it up to this point, I'm connecting to Kepware, I see that same data point over here, so I'm building that lineage and then ultimately pulling that into ThingWorks. So I have things like the space, the set point, the current humidity reading, the room temperature. And I know that if I look at my space humidity here at 30.77, I should see that same value over in my ThingWorks mashup where I'm using that data point, or with maybe a slight delay, but it should be pretty close as the data points are rolling in real time. With, I think we're set at 250 millisecond refresh. So the other dynamic here that is worth mentioning is within our network, we did something where we rolled up all of our data points, and we did that through an export table. And so our Titan is looking at everything behind it on the controls network. There's the Power Scout and the web RLN, and it is exposing all of these data points from a single point, or from a single location. So when we connect with Kepware, we're really only going to be talking to this server. And by putting all of these data points in an export table, I'm able to get all of those values. So with that, look at the, if you keep in mind this path, drivers, BACnet, box 2. Here in a second, we're going to see the exact same thing in Kepware. So this is my Kepware server. And what I've opened here is a project configuration. And so Kepware is a couple different pieces. First, it's a runtime that basically reads configurations, goes out, does the connection, pulls the data in, and then it does different things with it. For us, we're really in a store and forward mode where we're doing the connection via that proprietary or closed protocol. We're converting that into a ThingWorks protocol, and then we're sending the data on to ThingWorks. So if I set up a project, what are the big things that I care about? A project, think of it really as a set of instructions for the runtime to use. Well, I have to have channels, and a channel is really just a way to connect. So if I go in and what are my properties for my channel, the big one here is what driver am I using? For us, we're using BACnet, and that's how we're connecting directly to Honeywell. First thing I'm going to do is really just do a scan of the network. And when I did that scan, I see everything behind that server. I see the Honeywell, or the main server, and then I see these two different boxes. We're not going to connect to them because we want to minimize that network traffic. So I went into the device that I wanted to interrogate, and I have this neat little capability, generate tags. So what I did there is once I connected, I went out and said, hey, Honeywell server, what data points do you have? And what it did, it responded to me with that export table. Here's what I got for you. So what was generated was this list of tags and all the properties associated with it. Now, there's a lot of other data in here that you probably don't care about in a business context or a mission context, but things like description, name, the present value, and those are probably the big ones. Maybe you care about the units it's in, but that really gives you that business definition. And so then as we connect and pull this data points in, eventually we're going to get to the point where we down select, we only pull certain properties in to our thing objects. If I want to see what is the system telling me, so I want to test to see is Kepware connecting and is it pulling those data points, I'm going to go up here and I'm going to launch this client. It's going to create a live connection to that, that runtime. And if I go down to this analog input 1, as if you recall, that was our humidity. And I scroll down to present value, it's pretty close to what that system said. So a little bit of lag in terms of data point versus when I looked at that versus when we pulled it up here. But I'm pulling these data points in, and this allows me to say, okay, what data am I getting? And is the connection working? How am I pulling this data through? One final thing that we're going to look at before we switch over to ThingWorks, at the master config or the project level, we have this ability to decide what are we going to do with it. And what we did is we created a connection to ThingWorks. So there's some configuration. This is all running on a local area network. So I've got an internal server, I've got some ports, I've got some security settings. But the key here is really going to be this thing name. And what this gives us is when Kepware connects to ThingWorks, where does it put the data? What thing is it associated with? And we're going to flip over to ThingWorks here, and we're going to see that this industrial connection server is sitting there as a thing, and it's standing back and catching all of the data that Kepware sends it. Too many programs. All right, so this is my composer interface. So I'm going to pull up this industrial connection, which if I go into browse, it's going to be these industrial connections. And we've done some various piece parts. But if I go into my different properties and go into Discover, what I'm going to see here is as ThingWorks, or excuse me, as Kepware starts throwing it data, this is all the data that Kepware is sending it. And as you can see, under that same structure of that project, those two boxes, I have this tag, input 1, and I have all these properties that are being stubbed at it. So this is our entry point. We're going to be, storing this information, as that central collection. And then from here, this is where we start to build our business model. So I need to start understanding my domain. In this case, it's the controls information. So how do I do that? Very easily. I'm going to start selecting properties that I care about. We're just going to do a couple here. So the value, the name, the description, and I'm going to click this button. And what I'm going to be able to do is say, what kind of template do I want to use? In this case, it's a remote thing. We've got a connection to that remote thing because we have a live connection. And this is going to be test web humidity. I'm going to save. And then here in just a second, you're going to see this red connection turn green. There we go. And what that means is this thing within ThingWorks is now starting to receive data. It's got a connection through that industrial connection server, and it is starting to pull data. So if I go into properties, all of a sudden now I see description, object name, and this should be my present value. And over here, this is what Kepware is sending me. It's a value of 29.8. Somebody must have turned a fan on. Here's the actual data point. And then here's my humidity. So these become then the objects or the things that we build our domain model around. And we did this without any code. We said, hey, these three properties, I want to make a new thing. I want to bind it. And then all just like that, the data starts being propagated. And then I can use these for other purposes. One other thing to note before we switch over to the user interface is for our CNC domains, because we didn't have a protocol to connect to, we didn't have a way to dynamically interrogate a CNC machine to say, hey, what data points do you have? These we had to build manually. So we went in, created a thing, so generic template, and we gave it a name. And then we also gave it a value stream. And the reason we gave it a value stream is so there was almost like a storage bucket or a catch bucket. So as I'm sending data from these microprocessors, this value stream here is standing back and storing all that data. Very important if you want to do time series type things or analytics on these things, to have a holding place for that. Because you could have other properties where you don't want to store all the values. You only care about the current value, almost like an on-off kind of thing. But for these particular pieces, we wanted to have a record of what data did we generate over time. So once we created the thing, we went into these properties, and each one of these values we created manually. And our script that's running on these microprocessors is basically connecting. It's saying point at CNC remote thing or CNC machine remote thing 11, and then it's posting data values based on different parts. And if this is running, let's refresh here. Yep. I see that set value switched over to cutting tool. Should see some axis positions change. It's about every 5 or 6 seconds, I believe we have it set. See bit life just reduced from 40 to 45. So the data is dynamically being posted to this as well. I see this connected, and that's because it's actively receiving data from that external source. So now I've got my things, I've got data flowing. I've been able to connect and model my business. I understand, I've got these data points. I understand what I care about. Now I'm going to build my user interface. So I'm going to switch back to PowerPoint for just a second. How do we do user interface? It's really simple. We take our business domain, the things that we understand, and then we iterate via wireframes with our users. This is how we think it should be laid out. Does this make sense? So it is very much an iterative process. This is versions, I think, 1 of 5 or 6 that we did in our eventual wireframe. But even early on, the theme of we've got 3 main buckets. We've got manufacturing environment, we've got energy consumption. And then what we did was we enhanced those user interface components to show things like status bars, to show things like trend lines. But the general buckets were all there in the context of that layout. From a detailed perspective, again, I think this is a simulation of a 3D print job, but I have these main blocks. This is how my layout needs to look. This is the information that I want to see come into these particular parts, or the way that I want to highlight that to the people that are going to be using that. So that's that general process that we walk through to build our user interface. So if I go over to our smart factory main page, there's a lot going on here. There's a lot of different things, but what we're going to do really quick is we're going to build a simple one to kind of show you how easy it is to build a mashup. So we're going to build a new mashup. We're going to make it a responsive one that allows me to flow data back and forth. I'm going to make it simple, but quite honestly, it's going to look exactly like kind of our interface that we have, a header, footer, and a top panel. So once again, haven't written a cent of code. This is test web mashup. I've got some parameters I can use there. I'm going to quickly go into design mode, and this is going to be my canvas. So from a drag and drop perspective, in this center pane, I want to change my layout. Maybe I want my 3 panels. So I click this button 3 times, and now I have a manufacturing panel, a power panel, and an environmental panel. I want to add some labels to this so that I can kind of describe what I'm doing. Drag that over. Change some parameters. 50, and this is factory advisor. So once again, no code, have a user interface. Maybe over here then, I want to pull in my humidity data point. So I make a label. I give it the name humidity. Do a little quick formatting so it doesn't look absolutely terrible. I remove that value. We stretch that a little bit more. Once again, haven't written any code in order to build this user interface. So now that I can describe what data point do I have, I'm going to pull over another widget. And this is going to be a value display. And it's critical that I have certain widgets do certain things. With a value display, I'm going to be able to bind data dynamically and refresh it on that user interface as it comes from the systems. So we're going to change these margins then a little bit as well. We're going to remove multi-line. There's lots of properties in here that you can just turn on, turn off, and whatnot. I go over here to filter. I'm going to add a data source. So I'm going to look at things. I'm going to look at tests. This is my thing. I'm going to say, hey, I want to know what kind of properties you have. I'm going to run a function, get property values, drag this over here. What this screen allows me to do is to say, when you start, i.e. execute on load, go ahead and get my values, and then I can do something with them. And click done. It's going to give me some data. And here are my data points. And this should be my present value. Drag this over. I'd say put it right here. Put it in my data field. So really quick, I can save this. And when I view it, pull it up, I have my label, I have my value. Obviously my formatting is a little off. And then I have that value display. So doing things like truncating numbers, changing colors, changing font sizes, all of that, very much a configuration. Layout is drag and drop configuration. And this is the tool that we use to build the factory advisor mashup that you saw earlier. Obviously, a lot more work went into it than what I was able to show. So with that, I'm going to switch back to the slide deck and take any questions.
John, we had a couple of, I've had some pretty good questions that came up. One was about, I've heard that a lot of IoT devices have cybersecurity concerns and that some are worse than others. Is there something we should be worried about?
So the research that we've done, there's a couple different dynamics there. First, the locations with which you put those devices and the external security profile you put on them is going to be critical, because there is no one silver bullet. And I think the expectation has got to be, if you're in that cyber field, that at some point we are going to get compromised. We need to know when we do. So the ThingWorx security model provides for single asset identification. So I know from every sensor, and I do that via application keys, what are valid connections. So the ability for me to make sure that only valid connections are sending data to ThingWorx is built into the platform. You know, as far as the individual security or network security pieces of the sensors that are on there, they do vary. Most of the customers that we've worked with to date have really segmented their controls networks and their sensor networks. So they sit within a network that doesn't have external inbound ability to compromise them. And then they're getting the data out via a single pipe. A lot of ways you can do that. You can do that with data diodes in terms of like classified, unclassified networks. So what, you know, one directional data flows. It really comes down to what's the use case. Most of the sensors that in the industrial space, those are going to be connected directly to control systems. Honeywell, Siemens, Allen Bradley, those guys. But definitely needed to do an evaluation as you look at sensor packages to make sure that you're not introducing extra, vulnerabilities into your network, because that does play into the overall security profile.
Okay, thanks. Yeah, that's one of the real strengths, right, of ThingWorx is the security and the capability built in, that sometimes if you try to roll your own, you're not going to get that same level.
Yep.
Here's another one is, would you have a case or example of digital transformation for office environments and not just manufacturing shops or labs? So get into, more of an office environment, or even like, probably can even talk about like a smart city or a smart location.
So we do not. I know that we can have some follow up. I know PTC corporate has done some smart city, smart campus type constructs. It's not an area that I have a ton of personal expertise or knowledge in, but the ability to pull data from various piece parts. The question becomes, because some of the prototypes we did years ago were more around energy consumption, lighting, things like that. And depending on the currency of the building, there potentially could be control systems in place for that building, like a SCADA system that does building controls. Question is, from a digital transformation perspective, maybe, what kind of insights, what kind of optimizations would you drive from the data that you would get? If it's looking at space utilization and deciding if you turn whole floors off and have people work from home, what does that do to my overall, cost model of, facility maintenance? And there's some interesting digital transformations, opportunities there. But keep in mind, digital transformation is about changing the way you do business based on the information you can glean from your environment, whether that be through sensors or other things. It ultimately results in a change, aka the word transformation. So what are the areas for improvement would be a piece of that, and then what data do we need to collect or start collecting, or figure out a way to collect in order to get to those outcomes? That's where I'd start.
Okay, thanks, John. Yeah, if you kind of look at the transformation of just something as simple as a thermostat, right? So, you had for years, right, thermostats where you would set it and it would run all day. And then we got into a little bit more sophisticated where you can program it. And now the ability with some of the, the more advanced is then you add in things like, is there anyone in the facility? So not just, I'm gonna have my thermostat, at certain temperatures, knowing that most people don't work at night, but what about on a holiday or whatever? And really just trying to take that data and trying to utilize it and making things just more efficient and more effective. Thanks, John. Another question is the development of new sensors keeping up with the increased capabilities of AI and ML and IoT?
I would say that from my knowledge, sensors are in some ways ahead of AI and ML in terms of things like human factor sensors and medical sensors and everything else. What lacks in a lot of the sensor development is the ability to get that data through channels. A lot of the sensor development that I've seen focuses specifically on the creation of the sensor itself. And then it needs to integrate with something else in order to push that data to either an IoT platform or some other kinds of controls network. So I think almost, if I were to make an assessment there, because we do a lot of work in the machine learning space, I think sensors are ahead of where people are really have the capacity or the capability to exploit the data coming off those sensors.
Okay. And then one last one, and then we're going to move over to the paint hanger, is what other connection protocols does Kepware support besides BACnet?
Like I think I said earlier, the laundry list, there's a specific listing out on the Kepware PTC website. I think it's over 200 now, and there's various flavors of different protocols. So things like Modbus, another big one, open protocol. There's drivers for Yaskawa robots. There's specific for the control systems on robotic assembly machines. There's those are the big ones that we played with. There's also open standards protocols like OPC that are more generic that allow us to do that. And then you have things like MQTT and other things that are also more industry standard. The challenge is with all of these control systems, most manufacturers have a slight flavor of how they've implemented different protocols. So even with something like Modbus that's been around for a long time, you've got 16, 17, 18 different Modbus flavors. And so, finding one that's either generic or as close to generic as possible is really the way to go. And that's where you potentially get into a scenario where you may need to have a converter. We've run into a couple scenarios where the equipment was so old, it had a Modbus flavor, but we had to put a converter between the piece of equipment and the controls network to even get it on the controls network before we could get it into, I don't remember what the control system was. It might've been Honeywell again. So we had to convert it to a protocol that even Honeywell could talk before we could get a hold of it. And some of that's just based on the age of the equipment.
Yeah, and I think that equipment we were talking was probably 30 years old plus.
It was old.
To kind of get the age of that. So, most newer equipment, has the capability and much more straightforward from a connectivity standpoint.
Correct.
All right, so we'll have a chance again after we get into the paint hanger for more questions. So feel free to keep asking. Great questions so far. So we're going to now switch kind of gears a little bit. We're staying kind of the same path, which is we're now moving into another demonstration, another exercise we've done with paint hangers IoT monitoring. And we'll get into that, and Stefan will take us through. So to kind of level set, as John talked about earlier, is what were really the goals that we set out to do with the paint hanger from an analytics dashboard. So you'll see the dashboard that Stefan has created and will show to us. It was originally, we focused on presenting this to the US Air Force, a dashboard that allows them to monitor the properties within their paint hangers. And you'll see the different type of properties, temperature, humidity, different characteristics of water, different levels of gases from a safety standpoint. So all of those are being measured. And then we simulated data based on the properties in ThingWorx, and we built a UI around that data. So you're going to see that we actually have simulated data similar to what we did with the CNC machines in our previous demonstration. But the key thing about this data is this really is representative of real type sensors that the Air Force uses and sensors that they utilize, and thus would be interested in a user interface. We look at the value that it delivered, and business value is really keeping the operation running in an optimal way. And you'll see the different factors and how can we keep a plane going from each of the different bays through the entire process and get it out and running. Identify environmental issues that occur and avoid shutdowns or rework. As you can imagine, having to shut down a paint hanger, whether it be in a commercial environment or with the Air Force, it's very costly. And the fact is, if I had to repaint it, you can imagine the cost from a rework standpoint. And then also maintaining a safe environment, which is key. And one of the key things we really in both scenarios is the idea is we want to know more about the environment so that the workers, the individuals in there, we keep them safe and we follow the compliance that is required for that environment. So John has kind of touched on this earlier, but I want to kind of reiterate the capabilities and the power of ThingWorx. And it plays out again in this scenario. First of all, is this idea of connectivity. All different types of devices is that strength, multiple different sources of data, and then to build it. The fact is we can build this, capability using the model and the capability very quickly and time to value. You'll see another example when Stefan takes us through just how rapidly you can build the IoT application. And then we can extend that out by analysis. So we can take all of this data and we can then start making judgments. In both these cases, we're really just showing you some day-to-day type of information, but we could extend that out and really start doing predictive or prescriptive type of analytics on it. And then managing it. So I now have the data, I'm reading it real time. I can do that, and then I can go back and the connected products and devices, I can make changes to them. I can alter my process. I can eliminate potentially a hazard environment for my workers. And then an experience. And that's kind of key to all of this is how is it presented? John kind of showed you when in the dashboard that he created is really getting information and feedback. What should it look like? How should the information be presented so that it is usable, so that whoever is the consumer can do that quickly. Also, the capability is it can go across different personas, and we'll talk about that a little bit more. So with that, I'm going to turn it over to Stefan to take us through really the use case for the paint hanger. Stefan?
Yep. So I'm first gonna, like Jim said, outline the paint hanger use case. So first we have our manager of the actual paint hanger. The paint hanger itself has around, just for the purpose of the 7 bays that is each capable of housing and painting an entire aircraft. Inside of each of those bays, the aircraft being painted has to go through 3 steps in order to get completed painting. The first step in that process is the preparation stage. In the preparation stage, the paint or the plane is first sanded of all its paint or applied with a solvent to get rid of the old paint. The reason being applying a new paint layer onto an existing old one could provide unnecessary weight to the plane, which, you know, if it's a cargo plane or something, it's needing to balance out all the way that it can. And once the plane has been properly sanded down / applied with a solvent and stripped of all of its paint and down to the bare metal, it can begin getting painted in the paint stage. In the paint stage, when the aircraft is painted, it is applied with a spray painting gun, which has a high pressure, low volume system that allows it to apply thin layers of paint that also look very good. And during this process, because of the spray painting guns, hazardous chemicals are introduced into the environment. And so the manager is needing to monitor certain properties within the paint hanger to make sure that the plane itself isn't being harmed due to the excess hazardous chemicals, and that the employees themselves aren't being at risk. And once the plane has been painted properly, it can go and begin drying in what is known as the cure stage. In the cure stage, which could potentially last anywhere from a day to a week, depending on the size of the plane, the plane just dries. And during this time, the hazardous chemical properties that were being measured in the previous paint stage also need to be closely monitored now to make sure that all of the hazardous chemicals are going out of the hanger at a good rate. And so now that I've outlined the use case, I'll go ahead and kind of describe our interactions between us and the client when creating this paint hanger dashboard. So we first talked to a bunch of experts at the Air Force regarding some of the issues regarding their data. And one of the issues was data availability, in that in a paint hanger, they have multiple of those throughout the country, and they can only see the information locally. So they can't see information from other paint hangers if they're not there. So they're just needing a single consolidated view for everything so that they can provide predictive maintenance on that data. And so at ILW, we began by creating some wireframes, which is just conceptualized UI design. And we designed the flow from screen to screen based on what exactly they would want to see and what data is most important to them. And we completely customize those around the customer's needs. And throughout this process, over the course of a couple weeks or every couple weeks, we would go back and talk to the experts to make sure that we were on the right track and make sure that what we were going to provide in the future with the actual UI was something that, you know, we were shooting towards. And so we began then, after all the wireframes were complete, to design the user interface using the ThingWorx Mashup tool. And we just added functions based on user needs and displayed the data in a way that was best for them. Again, we would go back every couple of weeks just to make sure that we were on the right track and that what we were showing to them was what they were wanting. And so from there, I'll go ahead and show you guys the actual paint hanger dashboard that we created. And for the purpose of the demo, I'm just going to be assuming the role of that manager that I outlined before in the use case. And so this is what I would see on an overview of the hanger. I can see all the bays that are currently being utilized, as well as the type of plane that's in the hanger. And I can see the current progress of the project, whether it's in the prep, paint, or cure modes, the modes I mentioned before, as well as some pertinent property or pertinent values about the properties. So for water quality, you can see a grading scale on that. I'll get into that in a minute once I view this bay one in detail. And you can also see some comments about if a sensor is broken and needing attention, or if all the systems and sensors are good. So knowing that, what I'll do is I'll hop into bay one and just show what it would look like when completing a project. So this is what I would see when entering into any bay, specifically bay one. I can see the type of plane that's being painted, as well as a start date and an end date for our project. Down here on the left side, you can see all the properties that are being measured within the air, the temperature, humidity, and the airflow. As well as on the right, you can see the water quality, which is properties pertinent to the spray painting guns. So this water hardness is just a scale of how hard the water is, meaning that there could be particulates in the water, and depending on the level, could be hazardous to the plane when being painted. So we have a green scale for soft and a red scale for hard, and that color scale is also reflected here. And so once that I'm satisfied that the plane is ready to begin being painted, I can go ahead and click here and enter in the paint mode. You can see that more values popped up on the left. And like Jim mentioned earlier, you can see that these caution errors appear for when those values reach an undesirable range and attention is being needed and perhaps the hanger needs to be evacuated. You can also see on the left here that we also have a time series chart. Those are for most of the properties here, where we can just look at the behavior over time of some of the properties. And I can go ahead and enter the cure mode once the paint portion of the project has been completed. On the right, since the spray painting guns aren't being used anymore, we don't need to measure those properties. But on the left, like I mentioned earlier, we're still needing to measure these hazardous chemicals. And to make sure that they're dissipating at a safe level. And so those are displayed throughout the paint and cure process. And so now that I've shown you how the paint hanger dashboard works, I'll go ahead and describe the technology, in which I'll show how to, or describe the technology we used and sort of how to build it, and provide simulated data inside of here, much like the data was changing on the properties. So in order to get all of that hooked up, we first started with the Edge microserver. The Edge microserver is a series of files provided by PTC that allows us to connect to ThingWorx, as well as it makes the connection available for the Lua script resource, or LSR. The LSR just allows us to identify a thing and create it, as well as give it dynamic data changes throughout the whole, like when the script runs. And once the Edge microserver and the Lua script resource are both running correctly, they can go inside of ThingWorx and create a thing. And inside of that thing, like John had showed you earlier, all those properties are received, and the data that's being received is properties that are posted from the Lua script resource. And then after that, we can take those data points and put them into context inside of the user interface, or that dashboard that I showed you earlier inside of the ThingWorx mashup tool. And so from there, what I'm going to do is I'll steal the screen back from Jim, and I'll just show how to create an Edge microserver, install a thing inside of ThingWorks, and then from there, show how to write a Lua script property and add it inside of ThingWorks. So here is the directory that houses all those files that PTC provides to connect and configure the Edge microserver and the Lua script resource. And inside here is one of our configuration files where I'm just going to identify our ThingWorks instance by typing in first the IP address and inserting the port number. This just allows us that this just makes sure that we're connecting to the appropriate ThingWorks instance and that all the information is posted to our correct thing. And I also need to insert an application key. An application key is just an authentication token to represent specific users. So I'll take this key ID down here, insert it here. And inside of this file, that's all we're needing to do in order to identify our ThingWorks instance. From there, I can go inside of our configuration.lua file and name the thing so that when we create in ThingWorks, it's knowing that we're posting to this thing in specific, as well as add a template name. The template name's already been created and is up here, and we just have to insert the name of the template. And the template name is also needing to go inside the template file here, so it's identified. And so that's all we're needing to do within those three files to connect to a thing inside of ThingWorks. So I'll go ahead and navigate to the ThingWorks composer. I'll create a new thing, which I identified within the Lua file earlier. And once I save it, we'll see, like John mentioned earlier, this little disconnected screen. Oh, sorry, little hiccup. So in order to get this connected, what we're gonna first have to do is run the Edge microserver and the Lua script resource. So I'm just gonna execute a couple of those files real quick. And once I've executed the Lua script file, this should take a couple seconds and then connect. This is how we created our thing to post all of the data that was inside of the dashboard. And in order to show you how to write a Lua script file or a property within the Lua script, I'm just going to be using the thing that we created for our paint hanger dashboard. And so I'm just going to navigate into the file where we created all those properties. And first, what I'm going to have to do is create the property specific to how it's going to look inside of ThingWorks. So I can specifically name it the Bay 1 crew member sensor because I'm going to be posting it here. And what I'm going to do is I'm going to give it a base type of a number because that's the type of data it's going to be portraying, as well as a push type and a default value. And so that's all we're needing to do in order to create that property and connect it to ThingWorks. But in order to give it the dynamic data, how you saw with these numbers changing every so often, we have to create a variable. And I'm just making it a random number in between the values of 15 and 25. And in order to make this value equal to this variable, I'll just take the value of this variable or the value of the property and make it equal to that variable. So that just tells ThingWorks that when this script runs, it'll take this number and make it in between 15 and 25. So in order to see those changes reflect, I'm going to have to do the same thing with this thing like I did with the earlier one where I run the Lua script file. So you might see this disconnect. Just allow me a few seconds to run that. So once I refresh it, it should be connected again. And if I go into the Manage Bindings button, which is just, it manages the properties that are within the Lua file. So as you can see on the right, we have the properties that are already been added. And on the left, we have ones that are available to be added. So we can see that the Bay 1 crew member number sensor made the update. We can drag and drop it on the right and add it. And once I save it, you can see that when I refresh it every so often, it will change values with, the script that I gave it earlier. So now to put it in context, I can go inside of the mashup tool. Just wait for this to load. And what I can do is I'll be, like John had shown you earlier, I can take the data that's supposed to be put inside there and bind it to the property that I just created. And after we save, I can go ahead and I'll click View Mashup again. And you can see that where this was a 0 before, it's now, relaying the dynamic data that I gave it earlier. So that concludes my end of the side of the presentation. So I'll go ahead and I'll pass it back to Jim.
Thank you, Stefan. I hope everyone found both those demonstrations and the exercise as interesting as I did. As John mentioned up front, we focused on a couple of different scenarios, but those can be extrapolated to many other use cases. So as we kind of just wrap up everything we've heard today, and really the value of connecting sensors in your organization, we want to take first a snapshot of what things look like currently in many environments with sensors that aren't connected. So we have systems of different levels that you go from the low level of just, sensing a process in a PLC level with the piece of equipment through, process monitoring like a SCADA system, and then into production execution. And if it was the manufacturing, we'd be looking at a manufacturing execution system, and or up into our business systems, whether those be, those could be everything from your planning organization, from ERP or any other type. So we look at those different levels. The challenges we have are that highly complex, multiple vendors are involved. We've got a mix of technology, both from modern and legacy. Systems are very rigid, very siloed, and there isn't a lot of interoperability. Thus, we have a number of challenges we have. We get out-of-date operational visibility, if we can get it at all. Our maintenance is very reactive. We get unplanned downtime. We get machines that go down because of a problem that we could have detected, but we just didn't have enough information. We lack flexibility. We also have a skills gap, and really being able to do this is time to value. How can, if I do go on this journey, how can I get value out of what I'm doing quickly? And what you'll see with an IoT capability, as we start connecting our sensors, we now have an environment that is connected, that we can build, we can analyze off of it, we can manage it, and we can provide a UI, an experience that can be consumed by all different types of individuals in your organization. And thus we now have an environment which is connected, it's connected real time. We can have a role base. So if I can have a view that maybe my plant manager sees, or my maintenance director, or it could be a scientist in a lab, or it could be an operator, whatever. It's each persona can have their own view. And then as we said over and over again is to build upon this is being able to do analytics. So I can start predicting what's happened. So I can start determining what I think will happen next and do that ahead of time. And then we can extend this out into a mobile world. And that's where everything is headed. The idea is being able to do these dashboards, but then having a phone where I can be anywhere and I can view what's happening in my environment and then really enhancing that with augmented reality. And as John said, something like a HoloLens or a RealWear device, or even your phone or tablet, being able to kind of take that whole experience and make it more interactive, and really being able to continue to wrap and extend this technology. So again, if we see what an IoT solution, this platform like ThingWorx can deliver to us, we maximize the revenue, we maximize what I'm spending because I improve my throughput. I reduce time because I can now develop things quickly. As you saw in both cases, we were able to quickly put together and pretty straightforward develop an IoT application that could be used. We reduce costs as a result because we're increasing productivity, we're lowering costs, we're increasing the efficiency of our environment, and then we improve quality, right? We can accelerate the security and the scalability of innovation, of products, services, and really operations. And we can do this across all different types of environments. So we thank you. Let's see what additional questions we may have that have come up since then.
Hey, Jim, I'm gonna go ahead and launch the last poll too, okay?
Okay, that'd be great.
Yeah, Jim, I don't think any new questions have been brought up.
I don't think we've had any new questions. As John said, if you have additional questions, feel free. If we actually, as Jim has this up with new questions, we really appreciate you staying with us and listening to what we kind of share with you. So hopefully some of this resonates with you, the whole IoT. Illumination Works would love to work with you in these areas like augmented reality, data science, data engineering, which we do all of the time, and we continue to grow our expertise. Feel free to contact John, Stefan, or myself. You've got our contact information here, and we really appreciate you taking a few hours out of your day to learn more about smart connected sensors. I'll turn it back over to you, Jim.
All right. I'll go ahead and finish this polling here in a minute. Thanks so much for tuning in today, and we will do some follow-up. I'm be sending out a survey here shortly. I'd appreciate if you fill that out, and I'm sure that Illumination Works will probably answer some more questions for you if you have any, and we'll possibly get you the slides if they're going to do that or not. I will leave that up to them. We will also, if you want to review the collider, you'll be able to, I'll send out the link to where you can review it also, okay? So I think that's about it. Thanks so much for attending, everybody.
Thanks for the opportunity. I appreciate everybody's time today.
Yep, definitely.